Good morning, everyone, and welcome to today's webinar over the 2018 Embeds. My name is Carrie Krause, and I will be covering setup and input for embed plates and embed angles. Feel free to type in your questions during the webinar, and I will answer them at the end. So we will start by looking at the setup. These are located in your job or fabricator options. Across the top, you have a concrete setup tab. And under the concrete job setup, you have an embed schedule. With any new job, there will be 3 default embed plates. So you can edit those and modify them as needed. So we'll start here by taking a look at EM1. There's a couple different ways to edit the embed. You can either double click to edit, or you can select it and click on the edit button over here on the right hand side. If I double click to edit, we have some general settings up here at the top. You can control your piece mark, the plate thickness, the plate width and length, and then you can determine if you need to have hole patterns, DBA patterns, stud patterns, or a mixture of 2 or all 3 of those options. On the right hand side of the general, we have the length, the grade, the surface finish, and the plate location. So right here, our EM1 is set to plate location of inside wall. So let's go ahead and take a look at that here. So if we look in our model, EM1 is located right here. And I see that the location of it is that it is inside of the concrete wall. If I want that to be default on the outside of the wall, that's in our options, concrete options, job setup, and your embed schedule is located right here. Going to edit EM1, and the plate location, we can change that to outside wall. And we'll take a look at that change here. And we see that the plate is now moved to the outside of the concrete wall. Okay. Back to EM1 here. I have the number of stud patterns set to 1. The DBA and hole are set to 0, so those will be inactive. So on my left-hand side, my stud patterns is what will be active here. So we have a pattern reference here. So as long as you have show images on in the bottom left-hand corner of this edit window, you have your stud material, grade, the dimensions, the length, the diameter, the stud head dimension, thickness and diameter, and the pattern. For this particular one, we have 3 rows and 2 columns with row spacing at 6 and column spacing at 6. Our E right here, which is our vertical edge distance, is set to 3. Now we can change the spacing here. So in this, we have 3 rows and all of them are 6-inch spacing. But if we wanted to modify that, I can have variable spacing. So if I place my cursor inside of the row spacing, right after the 6, I can put in a comma, and I'll go ahead and put in a 4. So the first distance will be 6, and the second distance will be 4 inches here. So I'll go ahead and say OK, so we can see that change. I'll change this to stick and get it out of our way here for the time being. And we'll go ahead and take a look at that spacing here. So the distance between the first 2 is going to be 6, and between the second 2 is going to be 4. All right, next on our list here in our Embed Schedule is our EM2, and by default this one does have hole patterns. You also have the option for nailer holes. Nailer holes allow you to set the number of holes, the hole edge distance, and the size. But in our EM2, we have our hole pattern here. So on the left-hand side, the only one active will be hole pattern. And we have the hole size, the number of rows, columns, the row spacing, the column spacing, the vertical edge distance. So as we see here, the row spacing right now is going to be 4. Now, once again, we can have variable spacing. So if I have 4 rows of holes, let's say between the first 2 we want it to be 4, between the next 2 we want it to be 3, and then finish it off with 4. We can do 4, 3, 4 to have that variable spacing. So let's go ahead and take a look at our model here. So our EM2 is located right here. So we see our variable spacing between the first 2 is 4, the next 2 is 3, and the next 2 is 4 again. So we do have that variable spacing. The next embed plate here, we'll go back to the embed schedule, is going to be EM3. So this one, the plate location is on the outside of the wall. The number of DBA patterns is set to 2, 0 in the hole patterns and 0 in the stud pattern. So on the left-hand side, the only one that will be active is the deformed bar attachments. And in here, we have control over the deformed bar material, the section size, the grade, the length, your end operation. So you can have none, which would give you a straight bar. You can have a hook or a bend, in this particular case, where you're going to bend it. Next is the distance to the bend, and then the bend angle. So we're going to have 4 inches before the bend, and then at that 4 inches, we're going to bend it 45 degrees. Below that is our pattern, so you can actually rotate these bars. You can set the number of rows, columns, row spacing, column spacing, the vertical edge distance, and horizontal pattern offset. Okay, so let's take a look at our EM3 here. This is located right here. Here is our EM3. Get a good look at it here. Okay, so we have our 4 inches here to the bend, and then at the bend, we are bending it at 45. Now that we have looked at the 3 options individually, now let's go ahead and take a look at mixing them up here. So inside of my EM5, I have a 3/4 inch plate with a width of 1 foot, length of 1 foot 6, and my number of hole patterns is 1. So let's take a look at our hole patterns here. I have 13/16 holes, 3 rows, 2 columns, 3-inch row spacing, 8-inch column spacing, and then the E distance here, since I'm going to put DBAs at the top, I'm going to want to set that E distance here. I have that set to 6, and that's where my hole pattern will start. If we look at our deformed bar attachment pattern here, so we have RB half with 836, 8-inch length. The end operation, I have it set to none, so it will be a straight bar. And then the pattern, I have 1 row, 2 columns with 8-inch spacing and 2 inches as that vertical edge distance. So let's go ahead and take a look at that embed here, which is located right here, which gives us the bars right there at the top, followed by the hole patterns. Okay, so those are a few different types of embeds. If we go back to the embed schedule, a few other commands inside of here. We have the Add Embed Plate button. If you use the Add Embed Plate or Add Continuous Embed, that will give you a schedule to start from scratch. If you want to build off of an embed that is already in here, you could select that embed and then use the copy button in order to copy that and then build off of an existing embed plate or embed angle. The last option here is delete. So if you have one highlighted like I have here, I would hit delete and it would delete the one that is selected. Okay, so now let's go ahead and add in some members framing to the concrete. So I'll go to 110 here. Okay, so I'm going to add in a couple beams. When framing into a concrete wall, it does not matter where on the wall the beam is framing to, as long as the member line falls on either edge or somewhere in between the concrete wall. For this example, we will be framing to the center of the concrete wall. We'll have W16 by 26, and we will add that here. Okay, so we see here that we have a connection going into the concrete wall. Now, where does this connection come from? It is set to auto standard. So if we edit this beam here, I will see that the input connection type is auto standard for the left and right end. So if I go to my options pull down, job options, auto standard connections, if we look at our from beams category, we now have an option to concrete support. So from beams to concrete support. And the framing condition over here is the beams to the embed. And in this case, it's wide flange beam to concrete wall or embed plate perpendicular. So if I double click to edit that auto standard, I'll see that it is a shear with the embed schedule entry of EM1. And you have control over this just like any other auto standard connection. And while we're in here, let's go ahead and take a look at the from joist. You have the option to go from joist to concrete support. Okay, that is your auto standard connections. Next, let's go ahead and take a look at a detail of our embed. So if I have an embed plate in here, embed plates and angles are going to be stand-alone members. So if I select this beam, you'll notice that the embed plate is not selecting with it. So let's take a look at the detail of an embed plate here. So I'll select it, right click and show detail. It has not been detailed. We'll go ahead and detail it now. You do want to detail embed plates using templates because they have been modified to reflect what is needed for embed plates. Okay, so here is our embed plate detail. So it has two of them. We have one on each end of this beam here, and it calls out the studs and the spacing. Okay, so that is an embed plate detail. Next, if we wanted to change our input connection type, you can do that here. So if I double click to edit my beam, let's work on the left end here. We'll change it off AutoStandard. And let's say I wanted a narrow gauge clip angle. As soon as I change it to clip angle, I get a failed message. Since I'm framing to a concrete wall, it does want me to have a valid schedule entry for the steel to concrete wall connection. So 2 down from our input connection type, you are going to see that it defaults to none. In order for you to get an automatic connection in this case, you will need to change it to an embed plate from your schedule here. So I'll just change it to EM1, go down to narrow here, and say OK. Okay, so then it will give me the clip angle to the embed. Okay, and then on the right hand side, it's going to be the same thing. If I change it to shear, valid schedule entry required, and let's use EM2. And say OK. All right. So now if you wanted to edit this embed individually, you can. We have seen it edited from the embed schedule, but now this is its own member. So if I double click on the embed plate, you will see that I can edit this embed individually. So if I wanted to make a change to this, if I wanted to change my hole patterns here, let's say I wanted to change my column spacing from 9 to 8, and say OK, it is going to give it a new piece mark, but you do have that ability to change them on a case-by-case basis. The other option you have here is your support offset. This is going to move the plate up or down. If you want to move it down, it will be a positive number. So if I wanted to move this down, let's say 3 inches, it would be a positive 3. And you do have to mark it for processing here. Okay, so it will move that plate down. If you want to move the plate up, it will be a negative number. So I could move it up -3. Okay. Or if I wanted to change it back, I could unlock my fields here. It will set it back to default and go back to its original location and original piece mark. Next, I can set my beams to plain end. So I'll go ahead and set this end to a plain end. So you do not need to have a clip angle or a shear to have the embed in there as well. Now you'll see that I have a setback on here. The option to control that can be found in the options pull down, job options, field clearance information, and all the way down here at the bottom you have steel to concrete connections. Your end clearance is what it's giving us here. It's setting it back 1 inch off that embed plate. And then the pocket grout thickness is going to adjust the distance from the beam to the embed plate or embed angles. Okay. Next, let's take a look at the bearing. Get rid of this guy here. So if I wanted to have a beam bearing in a concrete wall, I could do that here. I'll add in, let's go W18 by 35 here. We'll change our input connection type here to bearing. And we'll use an embed angle here. Okay. So you see that it made a void in the concrete for the beam to bear on. And then we also have an embed angle there for it to sit on. If you edit the beam, scroll down to the bottom, you have control over the beam end pocket. You have your erection clearances, which include the top and side distance. Then you have the grout thickness, which adjusts the distance to the pocket from the bottom of the beam. And then the pocket depth. Now with this, if I move this beam, so let me go ahead and move this beam, and we're just going to move it over 3 foot. You will see that everything moves with the beam, the void, and the embed angle. However, if you delete this beam, it will delete the void, but it will not delete the embed angle because it is not connected to the beam. So when the beam is deleted, the angle is not deleted. So you will have to go in here and delete those embed angles. Okay. Now if we wanted to frame a beam to the concrete with no embed, we could do that as well. So let me select the 2 points here. Okay, it's remembering that bearing in here. Let's say that we wanted it to be just a regular clip angle with no embed. It does remember that the last embed that I used is an EM4. So if I select that field and just hit delete to clear that out, it will go back to none. We'll go clip angle on the right end. Get rid of our embed schedule. And we see the fail message here, valid schedule entry required. So if we hit OK, we are going to have a plain end beam with no connection. However, what you can do in this situation, if you do not need an embed, is that you can hit the force option up at the very top here for the left and right end, and it will force in a connection for you. And then you can modify it there as needed. Okay, so now let's take a look at joist framing into the concrete. So member add joist. Okay, and we will add in 30K10. We will make this a seated connection. So right now it's auto standard. We'll change it to seated for left and right end. If you have the option to extend the bottom cord, you will then have 2 embed options on each end. So on the left end setting here, I see that I have a top chord embed schedule entry and a bottom chord schedule entry and location. So let's set this top chord here. We'll just use EM1, and the bottom chord here, we'll use an EM5. EM6 here. Okay, so EM1 with an EM6. Okay, so we'll take a look at that. We have our seated connection with embed 1 and our bottom one here with a smaller embed. Go back here and we'll work on a bearing joist. So I'll add in a joist here. We'll add in a 10K1. One thing to note about bearing is due to the changes with the joist, plain end is now plain end, not bolted or welded as it was in previous versions. In order to get the option for bolted or welded, so if you were framing two wide flanges over top of each other, or you are framing a joist into a wide flange, you can no longer use a plain end and have the option to bolt or weld. You will have to use this option that I'm using here, which is the bearing option. Okay, so bearing allows you to control that cord to support bolted or welded. So this will be a bearing joist. We'll go ahead and set that top chord here. We'll go EM4, which is an angle. And the bottom chord here will go EM6. Okay, and you can have your location inside or outside. We'll come back to that here in a minute. Oh, let's see. Okay. Sorry about that. Let me redo that. Okay, bearing 10K1. Alright, sorry about this. We'll get this in here. So you see as I delete them, we do have the embeds that are sticking around after the joist is deleted. Alright. Okay, so joist add, intersection, we'll go here, here. Alright, so back to bearing. Remembers my EM4, EM6. I'll say okay. So we take a look at our EM4 and EM6 over here. Alright, so we see that I have an embed angle and an embed plate. The angle is on the inside, the plate is on the outside, that can be controlled inside of our edit window here. So my location, I could say inside wall for that bottom chord. It does need to be processed. Okay, the next thing we can do, we can edit that and we can change it to support offset. Let's say we wanted to set it down by 4.5 just to get it so it is not interfering. So we'll go 4.5. Okay, process it. It'll move that down. And we'll go into the embed schedule. That was EM6. We'll edit that, change it to inside wall. Okay. Mark that for processing. So now they are not interfering and they are both located inside the wall. Okay, also with that pocket here, you can double click to edit the member. Down at the bottom, you have your joist end pocket, which is going to give you the top and side clearances, the grout thickness, and the pocket depth. Okay. All right, so next what we're going to do is we're going to go over a couple different options that you can add to your toolbar. So if we go to our options pull down, we have our toolbar configuration. Inside of your toolbar configuration, the command group is going to be model-parametric. So model-parametric. And if you scroll down a little bit here, you will find these two options here. One of them reads Embed Plate Multi-Add Tool. So we'll go ahead and throw that up there. The other option is the Embed Layout Add Tool. We'll put that up there as well and say OK. So what these allow me to do is I'm going to open up my 120 here. And on this elevation, I have 3 beams that are away from the concrete. And I'm going to want to add an embed plate to them. So this embed plate multi-add tool is going to allow me to add a plate to a member that is not framing to concrete. So we'll take a look here. I select that embed plate multi-add tool. It's going to prompt me to select my beam. So I'll go ahead and select the beam, right click and OK. The next thing it's going to ask for is to select the end or ends. So if I just wanted to add it to 1 here, I'm going to right click and say OK. It's going to ask me what I want to use here. Let's go ahead and use EM3. And I can also modify any information as far as the hole patterns, the DBAs, or the studs, along with the left and right end elevation here. So I'll go ahead and say OK. EM3. A little bit of a hiccup there. Go to EM1. There we go. Okay. So it has added that embed to the end of the beam. Now what I could do is I could force a shear tab on there. Okay, so I could say right end, I could tell it shear. Okay, no supporting member, we can force it. Say OK. Let's try clip. Okay, there we go. So you can force it to get a connection to an embed even though you do not have the concrete wall there. If you delete this member, the embed will stay. If you delete the embed, the member is not graphical because it was never connected to the member. So it was not material that was added to the member. It was just a member added in. Okay. Now that was to just one end, but this tool allows you to add to multiple ends. So if all three of these beams needed to have an embed, I could add them all at one time. So if I say Embed Plate Multi-Add Tool, I can select all my beams, right-click and OK, and select all my ends, right-click OK. We'll just add the EM1 here. It'll take a second. EM1. Must have clicked it a couple times there. So we'll say OK. And there is EM1 added to each end of all three of these beams, all at one time there. Okay. The next tool here that we're going to look at that we put on our toolbar is the Embed Layout Add tool. We are going to add in a continuous embed angle. So before you can use the Embed Layout Add tool, you will need to have embed angles in your embed schedule. So right here in my concrete job setup, if we go to Embed Schedule, you can use your Add Continuous Embed here. We're going to be using my EM8. You can set the piece mark, the angle section size, your number of hole patterns, and in this case, the hole pattern 1, you can tell it which location you want the hole in. If you want it in the vertical leg web, the horizontal leg toe, or both legs. We're going to take a look at the vertical leg web, the hole type, your column location spacing. So in here you can either put a hole on the left end, you could put the hole on the right end, both ends, fixed edge distance, or fixed spacing. So in this particular case, what we're going to do is we want the holes spaced out 1 foot 0 with the left end distance of 3 and a right end distance of 3. You can also control the stud patterns or DBAs depending on what you need for the angle. And you also need to put a length in here. So I am using this particular embed angle as a continuous angle, so the length of it is going to vary depending on the points that I select. But you do have to have that field populated in order to use this angle. So I just put in 1 foot 0 just so we can use the angle. We're going to add in some joists here. Okay, and we'll go here, here. All right, and we will have a 12K one here, and we'll be framing to the top of the concrete wall. A little bit of a lag here. All right. So the right end here will be bearing. We're going to use our EM7, which is a DBA embed here. We'll say okay. Let it process here. Right click to return and take a look at our. All right, so we have it bearing on the wall. We have our DBA embed there. Now if we want that spread across here, I'll go ahead and make some copies. We'll copy it. We'll just space them 5 foot here. Wait for it to catch up. Alright, so they all have their embed plates. Now if we wanted to put in some angle to act as a support along with our joist for some decking, we can use the Embed Layout Add tool, and we can add it all along these points here. So I'm going to select the left end of the angle and then the exact points of all of these joists. Okay. Now each point that I'm picking here is going to be the end of an angle or a splice. Oh, let's throw in a construction line there. Keep everything in line. Okay, so each point I pick is going to be a splice location. And we'll see the dialog window here in a second. Okay, and at the end, we're going to middle click to OK. And here's our layout preferences. So you have your minimum length. So what's the smallest length that you want for the angle? What's the maximum length? So you could do a span and it will give you the angles in 20-foot chunks with this setting. Your start setback, your end setback, your splice clearance. So every point that I picked, which was in the center of each joist, I want a 6-inch splice clearance there. So I want to give it some room where we have the joists in between. And then a corner operation. So if I was going around the building, how do I want the corners to be handled? Either miter or butt. We'll say okay. The next window will come up, which is going to ask us for the Embed Schedule entry, which is going to be EM8. We'll notice that we do not see the embed plates listed in here to select from. These are only for the embed angles. So we'll say okay. It brings up the rotation, so we could rotate it, or you could change the different hole patterns to be different than what is in setup. We're going to stick with our fixed spacing at 1'0". We'll say okay. And we're going to have an angle with some holes on it to connect to the concrete with our 6-inch splice in between so it does not run into our joist. So now if we wanted to add an angle along the side here, what we're going to do is the Embed Layout tool. We can just go from one corner to the other angle here. Okay, and we'll use EM8. And that will add in another support angle, let's say for our decking. Okay. All right, those are the features that are included with the Steel license, and that is going to conclude today's webinar.